In this video, brought to you by the IET Surrey Local Network, we are joined by John Collomosse, a professor at the University of Surrey and also a researcher at Adobe, to answer the question, deepfakes, where did that image come from? By answering the question of where does media come from, we'll be able to address the growing problem of content authenticity that's facing society today. So it's over to John, who in a packed talk, illustrated with many examples and videos, took us through the answer to that question and also addressed many questions from the live audience who were joining us in Guildford for the event.
Yeah, very briefly, so as Colin introduced, I'm a professor here at Surrey. I also lead a team at Adobe Research, and both of my teams intersect in this area of content provenance, which is about finding out where media comes from. Many of our works indeed do draw upon artificial intelligence. They also draw upon a technology called blockchain that some people may have heard of as well, or more accurately, distributed ledgers. So what I'll try and do is introduce some of those technologies as I go through the talk. So yeah, provide an intro on that too. So let's get started. So indeed, fake news is a major societal problem. It touches really everything from our democracy to our healthcare, to wartime propaganda, to all sorts of areas. I mean, we have an election coming up most likely in the UK next year and indeed in the US, and no doubt the topic of fake news and misinformation will be prominent in the media there as well. It's not a new problem though. Most likely it's as old as the written word, and we can see here in this proclamation dating back to the time of James II, this is a photo I took here in the National Archives. I'll talk more about a project I did with the National Archives later in the talk, but you can see, even with the little F as an S there, dating it back to 1688. It's a long, probably dated far back beyond this document as a societal challenge. Fake photography is not new either. These are famous early examples of fake girls. Girls interacting with fake fairies at the end of the garden, and they fooled people for decades until sort of confessed to be cardboard cutouts by their photography, L.C. Wright. Today in our digital connected world, tools for capturing, manipulating and sharing digital media make this problem even more commonplace. It's within everyone's means to use and abuse these digital tools. And these are just a few sort of snapshots of stories. Goodness knows I could have picked so many examples for this slide, but we have here perhaps one of the most notable recent examples, the AI-generated image of the Pope. We have examples here of the deepfake Queen Christmas address. I think some people will remember that from a number of years ago on Channel 4. The deepfake Tom Cruise, and indeed headlines about how we might try and address this problem of deepfakes in the upcoming elections. Interestingly, we've also got examples of images that aren't manipulated at all. They're just images that have been used out of context. And that's an important point to note as we go through this talk, because actually, when you think about it, this problem of identifying misinformation is not really equivalent to the problem of identifying manipulated or fake images. Human rights organizations like Witness.org will tell you that most misinformation, visual misinformation circulated online isn't manipulated content. It's just images that have been used to tell a false story, unaltered images that have just been misattributed. And actually, when you look at imagery, most of it is manipulated anyway. It's been touched up, it's been cropped, it's been white balanced, whatever. That intersection between manipulated images and misinformation is actually super small. And trying to address the problem by detecting manipulated images in that intersection is just an arms race. You're trying to build better detectors that will outsmart the generators, and then the generators will outsmart the detectors, and so on and so on. And right now, nothing moves faster than generative AI. So actually, you're not going to win that race. So the approach that we take in my team and in the initiatives affiliated with, we take a kind of different view. So rather than deciding if an image is fake, instead we try and inform users about the provenance of an image. What does a provenance mean? It's the origins of an image. Okay, so like how it was taken, by whom, what was done to it, that audit trail behind an image that describes its path along the creative supply chain, if you like. Okay? And what we want to do is show that audit trail, that provenance information to consumers of the image so they can be better informed to make trust decisions about that content. We don't want to decide for them if something is trustworthy or not. How could you? It's so subjective. We don't even want to tell them necessarily if it's manipulated or not. We want to just tell them where that image has come from so they can make their own decisions in an informed way. That's what we mean by provenance. Instead of detection, we're about provenance. I want to try and convince you also within this talk that actually provenance can do a lot more than tell you about the authenticity of an image. It can also help you do things like identify who could be credited for an image, improve attribution for creative work. I guess everyone here must be aware of models like DALL-E, Midjourney, Stable Diffusion, these kinds of AI models. They're called generative AI models that can create images just from simple text descriptions. How do they work? They just synthesize a load of noise and then gradually use AI to create structure from the noise, iteratively by creating noise, removing the noise, creating it, removing it, and eventually generate an image like the sunflower here. How can they do this? They're trained on millions, if not billions, of creative works. And rightfully, creative practitioners are concerned about the use of their works in creating these generative AI models because they want to be recognized, maybe even rewarded for the use of their work in this context. So this issue then of data provenance, what data was used to train my AI, is really in the public eye at the moment in a way it hasn't been before. We want to know where our AI model came from. We want to know where the data that was used to train our AI model came from. And ideally, we want to be able to make deductions about what training data was used to create particular images from that AI. And if I can do that, maybe I can attribute credit more fairly to the contributors of that data, maybe even reward them either reputationally or financially. So this is what we call the attribution problem, and it's a facet of provenance that I think is increasingly important now in the age of generative AI. So I want to start with a few photos of inside the UK's National Archives. This is a project that really got me started in the area of provenance, and that book on the right is a tome of kind of swatches of material that constitutes a part of the UK's record of registered designs. Lots of textile patches that, swatches of cloth that record over 200 years of design. It's a record of design provenance, and we had an interesting academic project back in 2017 looking at how we could search that archive and digitize it. But like many institutions, the National Archives are dealing with digital transformation. They're trying to figure out how content that arrives born digital can be protected. Even things like social tweets these days have relevance in policy that they didn't have several years ago. So how can we explore this problem of digital preservation in a born digital age? Well, in this project, which we called Archangel, we sought to do that by combining AI with a technology called blockchain. Now, a very quick way to explain blockchain is actually using something that we found in the archives, which is called the rolls of chancery, which are kind of medieval court records, bits of parchment that have been stitched together into a patchwork that make up this roll. And even today, the second highest judge in the land is called the master of the rolls, for looking after these rolls. Now, the motivation for stitching together the court records into this patchwork is not only for efficient storage in a roll, but also the idea that nobody could remove a page of those records without someone noticing the big gaping hole there in the roll. And that is kind of how blockchain works. Blockchain is about stitching together records of data with hashes, digital fingerprints, that bind together the data so that if someone removes or alters one block or patch of data, then it would be noticeable, it would be tamper evident. And we leverage this technology with AI to build a system to underwrite the integrity of national archives around the world. So this project Archangel then is basically using blockchain and AI in the following way. Let's say that we take a video, like a record, like a Supreme Court proceedings, which arrives at the National Archives in a born digital form. And it might be the case that that court proceedings can't be released to the public for 5 years or something, okay? And in many cases could be longer. So how can we assure the public that that record has integrity when it is released, that no one's tampered with it or accidentally corrupted it? What we do is we use an AI system to fingerprint that video, create a digital fingerprint, and then store that fingerprint in a blockchain, which is like a big public ledger that is immutable. Once you put something in a blockchain, you can never remove it by virtue of this kind of binding together of the data I mentioned. And then later on, when the record is released to the public, people can fingerprint it again using the same network and verify for themselves that that content has integrity, that it hasn't been tampered with during its time in the archive. And the network is trained in such a way that even if the video gets transformed during its curation in the archive, it's part of the curatorial duty of an archive to make sure that records are always viewable using current technology. It might be that the format of that video has changed many times during its curation. It doesn't matter, the AI will still give you the same fingerprint. It's what's called a content-aware fingerprint. So we deployed Archangel across national archives of 5 different countries for trial. Who knows their flags? Well, obviously, we've got a US national, so we had NARA, which is the North American National Archives, led by the UK National Archives. We've got Australia, Norway, and Estonia. Estonia, very keen on blockchain. You can do, they've got a blockchain-based sort of digital record of government. You can do everything except die and get married on a blockchain in Estonia, I'm told. And anyway, the idea is that the archives mutually underwrite the integrity of one another via the blockchain. So the idea here is that we're moving from an institutional model of trust me because I'm the archives, to a technological underscoring of trust. And that's increasingly important in a world where sort of institutional trust in organizations is being eroded. So yeah, so Archangel was the first to do this kind of digital preservation using a blockchain. This is back in 2017. And as I say, it used an AI model, a deep learning model, to create that fingerprint of the record. And this idea of creating a digital fingerprint of a record, like an image or a video, that doesn't change, even if the content is transformed across platforms, is renditioned, as we call it, underpins quite a few of the other innovations I'll share with you today. The idea here is that, if I have an image, for example, on social media, if I take what's called a SHA hash, it's like a cryptographic hash of that image, fingerprint of that image, even if one pixel changes a tiny amount in that image, the hash will completely change. But using this AI technique, even if the image has changed resolution, quality, but basically contains the same stuff, the AI, the deep visual fingerprint, will be the same. So that's what we used. So I'll come back to how that's useful in more context later. So yeah, this idea of like authenticating content online is something we've been addressing in close collaboration with the Adobe-led Content Authenticity Initiative called CAI, which has over 2,000 partners now, academic partners, organizations in industry as well. And the idea here is that CAI is tackling misinformation through provenance. It's basically as a content attribution problem. As I mentioned earlier, we're not trying to detect and automatically judge the veracity of content. Instead we're putting users in a more informed position to make trust decisions about content through provenance enhancing tools. And the thesis, if you like, is that by enabling a solid provenance layer, we can stack on top of that a use case which is basically judgment about the authenticity of content to fight things like misinformation and improve content attribution. But thinking a little bit further into the future, actually, there are other things we can layer on top of that capability stack. If we've got content with provenance and we can be assured about its authenticity, then maybe we can start creating decentralized markets for content. So, for example, if I'm a freelance artist and I want to, sell my content digitally online, I'll be able to do that a lot more easily if I can guarantee people the provenance of that work and also that it's authentic. Interestingly, there was something, I guess it came to prominence a lot during the pandemic when traditional routes for creatives to sell their work were kind of shut down, like galleries and so on. This rise in digital trading of artworks through something called NFTs came to kind of the fore. NFTs were an example, perhaps like a V1, a version 1, of a decentralized market for creative content. There were huge issues with NFTs. We can talk about some of those later. But they were notable in being the first example of a decentralized market for creative content. And yeah, largely used in their initial form to do things like trade images of, you know, cartoon characters and all sorts of things, you know, as collectibles, basically. But, you know, this idea of creating a digital token to represent an artwork and trading it has future applications in things like the ideas around metaverse. So a metaverse is kind of the idea of a 3D immersive environment, and there might be multiple metaverses that interoperate and create value through the exchange of digital assets. Well, provenance and content trading will be important to that. Maybe thinking even further into the future, perhaps an even more exciting question would be, how will these technologies affect the way that we work, or even affect creative practice? I mean, imagine a future in which content provenance enables us to determine the attribution, the authenticity, the rights, even the pricing of content in a world where anyone can generate content. Let's suppose that I'm at a gig here, and you know, I'm taking some footage on my smartphone, and BBC are there to be filming it too, and they want to produce a documentary. Maybe they can license my content dynamically through a pricing system from my phone and incorporate it into their production, and as a user, I get like a micropayment for that, maybe a royalty for that. So this idea of creating decentralized markets for creative content is something that provenance technologies could underpin, and are beginning to in these early sort of versions of things like NFTs. So let's rewind slightly and talk a bit more about this issue, first of all, of authenticity in the first layer. I want to talk a little bit about ways that we can create strong provenance for digital assets, like images or videos, using a variety of different technologies. And I want to start with metadata. What is metadata? It's data that sort of is carried along inside an image, information that's jumped to the image that describes traditionally things like, you know, where did the image get taken, you know, what sort of focal length the camera had on it, that sort of thing, all right? But actually, we can also use metadata to transport information about the provenance of an asset, say, like who made it, what tools did they use, that kind of thing. So there's an emerging standard called C2PA, which is a bit of a mouthful. It's Coalition for Content Provenance and Authenticity, and it's an open standards group founded under the principles of the Linux Foundation to create a metadata standard for describing the provenance of digital assets like images. It's all centered around this idea of embedding something called a manifest into metadata of an asset like an image. A manifest basically contains claims that are cryptographically signed, and the idea of this manifest gets added to as the asset moves through the creative supply chain from, say, a photojournalist with a camera with this stuff in it, through to maybe the BBC, let's take an example, as a news publisher, through a distributor, ultimately all the way through to the consumer. And the idea is that by enabling consumers with the tools to view this metadata and make sense of it, they can then say something about where an image has come from and therefore make informed trust decisions about that content. So there's quite a lot of jargon associated with this. You know, these claims that are signed cryptographically contain things called assertions, which are basically facts, like things like the identity of the photographer, the operations they performed. Did they use a crop? Did they use an AI tool? Was the image in fact made by an AI? These sorts of things can be encoded. And they're all bound together cryptographically and tied to the pixels of the asset using a cryptographic hash called a hard binding. This whole idea is rolled up into what's called content credentials, and there's a little logo there, the CR pin, and I would suggest that, you know, in the coming years you'll see quite a lot of this logo on various websites you know, to indicate the presence of this information in your assets that will allow you to inspect it and make informed decisions. It's a really exciting time as more and more people are adopting this. You know, even some cameras have this, and so on. So I want to just briefly show you this in action. Let me just switch over to a web browser if I can. So I'm not sure if I can. Yeah, there we go. So this is a website where you can drop assets in, like images in, to view their content credentials, to view this provenance information. So for example, if I look at if I pull up this image here, this is a photo that I took of when I got to climb the O2 as a birthday treat. And you can see here that on the right-hand side, these are the content credentials of the image. So you can see it was produced by me. It's also linked to some blockchain-related stuff, which is not necessary, but I can explain more about that later. And then it's telling here about the process. So, I used Photoshop to adjust the colors. I took it on a particular camera, this kind of thing. Okay. So, there was one sort of big challenge with this. I don't know how to get rid of these bars, so bear with me on that. There's one big challenge with the idea of having metadata transport this information around the world, and that is that metadata is very easy to strip. Okay, if I take an asset and I publish it on social media, for example, unfortunately today most platforms don't support this standard, and they'll just strip out the metadata, and I won't be able to see it anymore, won't be there anymore. So how can I deal with this challenge of metadata stripping? Well, if every time I sign this information into an image, I keep a copy of it somewhere, then what I can do is use a technology called content fingerprinting. Remember back to Archangel, we did the same thing, to take a digital fingerprint of an image I find floating about in the wild on social media without any of this metadata and match it back to my trusted database of this provenance information. And then once I've done that, I can then show it to the user as if it was always there in the image in the first place. And this will enable adoption of this technology across many different platforms that aren't compliant. It also helps mitigate the threat of attackers stripping off this metadata and even substituting it for alternative metadata. So how does this work? Well, in certain products, like for example Adobe's Photoshop, this technology is already in existence. And if I have an asset, like this image here, and I want to sign it to basically put this cryptographic metadata inside it, then at the same time as I do that, I can extract one of these digital fingerprints using AI and store a copy of that metadata in a database. It could be in a cloud, like Adobe's cloud. It could even be on a blockchain, which, as we know, is a sort of decentralized, immutable database I mentioned earlier, that patchwork of the court records. Then the asset might go out onto the internet, circulate around a bit. You would come across it on social media. It's been degraded. It's been renditioned into some different format. But even though it's been subject to those non-editorial changes, I can still match the fingerprint back to my large database of these fingerprints and restore the provenance trail of that image. Okay, so that helps us do things like gain better auditability of where images have come from on social media. How else can it help us with other problems that our society might face at the moment? Well, one big kind of concern that people have at the moment is this idea of generative AI images, and how can I tell if an image was made by an AI or not? Okay, and what we're seeing is a tendency for producers of generative AI images, synthetic images, to insert into them the metadata like this. Like, for example, there's a technology called Firefly that is Adobe's version of one of these generative AIs, and every image that Firefly generates, it will embed these content credentials inside it. And not only that, it will take a fingerprint and store it in its cloud, so that if an image is seen on social media anywhere, we can run this fingerprint search, match it back to Adobe's cloud, and say, yep, we made that, that's a generative AI image. And that approach to responsible innovation then gives better transparency and accountability about the use of generative AI. So this is an example, actually. When I was at work the other day, I saw one of these images in the cafe on the screen, and I took a snapshot with my camera phone, and I snapped it, uploaded it into this website that I just showed you, and indeed it shows me the content credentials of the image down the side. Let me flip back to my web browser again and show you that example again. So this time what I'm going to do is use the same image. I'm going to drop it in, but this time it's going to be a version of that image where the metadata has been stripped away. So in this case, when I load it up, it says, look, there's no content credentials in there. But then what I'm going to do is search for possible matches, and this is then taking a fingerprint of that image, running it against the global search index, and then indeed it finds the match of the asset that was created in Photoshop way back in 2022. And you can see here that, in fact, it restores the content credentials here down the side. So it's recovered from that stripping of the metadata. Okay. So, so my research group has explored many of these different content fingerprinting technologies. They've all got various names. The one I just showed you there, we published back in 2021. It's called OscarNet. We've also got technologies for highlighting the changes between images that we match circulating in the wild back to the originals. Maybe they've been manipulated. We could highlight the areas where they have been. I'll show you that in a moment. We've also got technologies for this that also work for video, and also, various security-related technologies to stop them being hacked. So let me just show you a bit more information about how this fingerprinting technique works. This is an example of the kinds of things, first of all, that we can match. You can see here on the left-hand side, we have an image that has been degraded, rotated a bit, but on the right-hand side, the corresponding original image that the fingerprinting system was able to pick out. These are top one matches, searching a corpus of around 150 random artworks from a website called Behance. How does this robust matching work? Well, we do what's called object-centric fingerprinting. So what we do is we use AI to identify the dominant, salient, as we call them, objects in the scene, and we independently fingerprint the visual appearance of those objects, and we feed them into a neural network. This neural network, I won't go into the details of the structure of, but it's based on something called a transformer, and basically this transformer learns how to identify images that have been subjected to non-editorial transformations, like degrading, sort of blurring, the sort of things that you saw on that previous slide, and tampered images where someone's like swapped an object or something in there. And by learning to tell that difference, we can learn to match images that have been non-editorially transformed but ignore and fail to match editorially transformed images, in other words, tampered images. How do we train such a thing? Well, we can show it lots of image pairs of original and manipulated images and have it learn the difference. I won't go into too much of the detail, but the system works considerably better than sort of standard approaches. So there's quite a lot of kind of classical fingerprinting approaches that use frequency coefficients and things that are the ones in blue. There's various ones that use deep learning but apply to the whole image. But our approach sort of does this piecewise object transformation, which sort of performs better. Another thing that we had to do, as I mentioned earlier, is protect this model against attack. There's a kind of curious form of cybersecurity issue with AI models it's called adversarial attacks, which is a bit of a silly name really, because of course all attacks are adversarial. But in any case, it's what they're called. And the idea is that you can take an image and just fiddle with its pixels a tiny bit, imperceptibly to a human. It will dramatically change the interpretation of that image by an AI model. And this has been used, you can take an image of a dog, twiddle its pixels slightly, and an AI will be convinced it's a cat, okay? And you can do the similar sorts of things with these fingerprinting models to fool them. And so we did quite a bit of research figuring out how we could maximize the protection of this model against this kind of attack. What happens when we do perform this match? Well, as I say, what we can do is start trying to highlight the areas of the image that have been manipulated. So, for example, if I've got this original image here of a roller coaster or log flume or something, and then here I've manipulated it so like the guy's arms are up instead of down, the system can spot that, even though the image has been deliberately degraded here. It's not the projector in this room, it's been blurred. How do we do this? We built a network called an image comparator network. It's another form of AI network that basically performs an intelligent visual differencing of the image. It compares the query image that we've done the fingerprint match with the matches that have been turned up via this large-scale visual search. And it highlights the differences that are due to manipulation, to editorial change, but it ignores any differences that are there due to non-editorial changes, renditions like warps or rotations or blurs and these sorts of things. It also gives an overall judgment as to whether the image is the same, subject to any of those non-editorial transformations, benign transformations, the same but manipulated or completely different. And we can use those scores to re-rank our search results for high accuracy, which is what we're showing here. I'm going to play a quick video here, showing you some examples of that system in operation.
Online misinformation and fake news are serious societal challenges that Adobe is proud to be addressing through the Content Authenticity Initiative. How often do we all scroll through our Twitter, come across a photo, like here, of the president, and we ask ourselves, how can we tell if this image is genuine? Content fingerprinting lets me quickly check the image against a database of authentic content stored securely by content creators in Adobe's cloud. I drag the image in, and the content fingerprinting tool shows me that the image is a partial match. It has been manipulated, and the manipulated area is highlighted. And now I can make a better decision on whether to trust the content. How about this image of Russell Brown? We see that it matches exactly to an image in the database. There's no manipulation. But now I'm going to edit that image in Photoshop, and I'm going to switch the wand out for an ice cream. So I'm making my own fake news here about Russell and the ice cream. I'm going to save it, and then I'm going to drag the image into the content fingerprinting tool. The system has made a partial match. Again, it's highlighted the manipulated area. Now I can make a better decision on whether I can trust this content. So as content gets shared around, it can also experience benign or non-editorial changes to the content, like format or resolution change, or here, quite severe noise and degradation. Content fingerprinting uses Sensei's advanced AI to match the images even if they change format, resolution, or here exhibit quite severe degradation. The fingerprinting technology highlights only the editorial change, the glasses, and ignores the visual artifacts from the noise and non-editorial changes.
So I'll stop the video there. So there we're showing how we can use a sort of a heat map visualization to identify areas of change between images that have been matched. Another more recent project has been to use large language models to describe in words the difference between two images. So large language models, I guess, is another thing that's kind of come into prominence recently in the media. These are sort of large AI models that can write natural language, and you can interact with them via text, much as you might converse perhaps with a human. The idea here is that we present a large language model with a pair of images and ask it to describe the difference between the two. The system that we produced, which is called Vixen, so it's the first two rows here in the table, basically shows how we can do that and produce a concise, human-readable description of the difference between the images, whereas some of the sort of other models that aren't based on large language models don't do such a good job, which are the other rows. So that's something from a paper we submitted. Another thing we've done is basically try and do the same thing for video. Video is challenging because, of course, there's audio as well as visual, and also, you want to do sort of temporal matching as well, because you want to match a short clip perhaps to a much longer clip. We made a system called VADA, which is video alignment and differencing, and there was a data set we released called Anakin as well, but I can't remember how we managed to shoehorn that in. And this is a video made by my PhD student Alex describing how that system works.
The second column is where we retrieve the original using the retrieval module. We use the alignment module to align the retrieved video and the query. Finally, we use the differencing module to outline the edited part of the video, and we superimpose that on both of the videos. Second is in painting. The person was removed from the video. So again, we use the query to obtain the original using our retrieval model, and as we can see, there is indeed a person walking on the street. Then we use the alignment to align both of them together, and in this case the alignment is very precise. As we can see, both videos go together frame by frame. Finally, we use the differencing module to obtain the outline of the person. And finally, an example of a swap manipulation where the query video is quite homogeneous, and because of that, the retrieved result, which is almost 4 minutes long, is not aligned perfectly with the query. It is aligned quite close, but there is a couple of frames discrepancy, as you might be able to see in the column number 2 here. We chose this example to show that even in the cases where the alignment is not matching the videos exactly correctly, the differencing module is still able to ignore the differences in the faces here, for example, and focus on the object that was manipulated.
Okay, great. So, so moving on then, I guess I want to present this slide here, which I think is, I hope, a good summary of different technologies that can help produce this solid provenance layer. We've talked about metadata, and we've talked about fingerprinting. There's another technology that's quite commonly used to identify media assets, and that's watermarking. And with watermarking, what we're trying to do is embed in the image, something called a watermark, which is like a sort of invisible signal that enables us again to match an asset back to a database. So just to recap, metadata is embedding information in this sort of that gets transported around.
Fingerprinting is basically taking a fingerprint out of the pixels and searching with it. It's not strippable, there's nothing to strip, but it's not that exact either, it's like a new duplicate match. And watermarking is sort of somewhere in the middle, I guess. It's sort of actually actively injecting signal into the image in an invisible way that can be used to trace the image. So all three of these technologies have different pros and cons. Are they stripped by legacy systems or are they not? Are they strippable by attackers or are they not? But together they sort of cover the attack surface in a comprehensive way to help us create this solid provenance layer.
So yeah, let me show you then an example of a watermarking technology that we've also built. And this was in collaboration with several teams at Adobe in the Content Authenticity Initiative. The idea here was to produce a browser plugin, browser extension I think they're called these days, which basically will look at the images on the web page and identify if any of them contain this special invisible watermark. And if it does, it will then basically pull the identifier out of that image, query the let's say, for example, Adobe's cloud to pull back the provenance information and display those content credentials to the user as if they'd never been stripped away by the social media platform, which, as I mentioned, is what happens routinely on all social media platforms. So let's have a look at that example. So if I go to this web page then, which is just a live Twitter page right now, then what we can see here is that as I scroll down the Twitter page, then some of these images here, they have this little CR icon that's overlaid there, you see, and that is the plugin, the browser extension doing its work. And if I click here, you can see I can get more information on the images that have been found here. So yeah, that just gives an indication as to how that technology works. Right. So, okay. So let's give a bit more detail behind the scenes as to how this works. Well, what's going on here? We've got a web browser that's running a browser extension. It's detecting the watermark. It's pinging some commercial provider. I mentioned, Adobe retains these fingerprints in its cloud system, and it's pinging that cloud system with the watermarked ID that it's found to get back, it's called a manifest ID, which helps us trace the manifest and ultimately display it to the user. Obviously, this is what we call a centralized solution. So in this example, it's only recovering manifests from one vendor. And what we want to see is that this technology is adopted by many vendors, many providers of these manifest stores, as we call them. So again, what we've done is leverage blockchain technology here in this demonstrator. And what we've done is we've produced this browser extension now, and instead of querying just one company's proprietary store, we're actually querying a global public database on a distributed ledger, on a blockchain. And we are using that blockchain to look up the watermark ID and tell us which company to go ask for more information from. And then that company then will provide us with that manifest, those content credentials. And we also perform a visual check to check that the image hasn't been spoofed. That's another extension we did. And then they get shown just as before. So I won't demo it again because actually the demo looks exactly the same. But behind the scenes, it can integrate with any number of providers, public and private. So yeah, I think this is another good example, and hopefully I'm showing a few of them in the talk, of where people think about blockchain as being all about cryptocurrency. That's all we see in the news, right, about blockchain, maybe even like the horror stories around it's, people abusing it in that way, followed by stealing cryptocurrency, for example. But actually, all blockchain is, it's like a decentralized database, that has distributed trust. So if you think about things like Bitcoin, well, what is Bitcoin? It's a cryptocurrency. What is it? It's basically a distributed system for tracking who owns what tokens, we call them coins, Bitcoins, without recourse to a centralized authority like a bank, right? But actually all that is a distributed database without a centralized point of trust. And what we're using this for here is, again, blockchain technology as a decentralized database, not for cryptocurrency, but to look up watermarks. I'll skip that slide in the interest of time. We've done the demo. How else can we use this decentralized database? I won't go into this diagram from our most recent paper in too much detail, but the basic idea here is that we are taking an image and, again, using the blockchain to look up these content credentials, this manifest, online in order to be able to get information about its provenance. One of the features of the C2PA standard is we can indicate inside the manifest something about the permissions that we want to grant people for use of that image. For example, an artist can indicate inside that piece of metadata whether they consent or not to having that image used to train a generative AI model, which, as I mentioned at the beginning of the talk, is quite, a lot of people have strong feelings about that at the moment. So this system that we call Decorate is like a decentralized registry to opt in or out of using images for AI training. In other words, to give creatives better agency over the way that their images are used. Another facet of the system is it allows creators to store within those credentials, for example, their cryptocurrency wallet address, so that they could receive automatic micropayments if people do choose to use their images in different ways. So it's looking again at this idea of decentralized creative economy and how we can enable creatives to generate value from their assets in new ways, as well as have better agency over the way their assets are used. So that brings us then to some briefer points that I'll make on how we can go beyond authenticity into the future and think about higher levels of this stack. Once we've established content provenance in a solid way using these three pillars, these three technologies, metadata, fingerprinting, and watermarking, and we can say something about the authenticity of that content and who it belongs to, then we can start doing things like trade those content on decentralized platforms. Now, I mentioned NFTs earlier. An NFT is like a sort of unique, indivisible digital asset, like a trading card or a piece of digital artwork. As I mentioned, NFTs kind of came to prominence during the pandemic when the creators were looking for new ways to market their content when art galleries were shut down, this kind of thing. Now, basically, NFTs derive their value from provenance. In physical artwork, value is also derived from provenance. Provenance is what gives the Mona Lisa hanging in the Louvre a lot of value, and my pixel-perfect replica of the Mona Lisa I might have on my bedroom wall, maybe, no value, okay? There's a physical ledger kept in Paris, the Catalogue Raisonné, that records the provenance of assets. It's a ledger. It's a physical ledger for recording the provenance of physical artworks from which value is derived. An NFT is like a digital analog of that, a digital version of that, okay? It is a digital ledger on a blockchain that records who has owned a digital artwork. And people may or may not value that record and may or may not decide to pay lots of money for NFTs, but certainly in some cases people will pay millions of dollars for them. What does that digital ledger look like? Again, we won't go into too much of the detail, but basically it's just a mapping that maps ownership of a URL to an individual. So when you buy an NFT online, what you're really buying is a statement on a blockchain that says, I own an image that's stored at this URL, at this web location. And this mapping is stored inside something called a smart contract, which is just like a kind of, like an object in an object-oriented programming sense, but on a blockchain. NFTs, obviously, there are lots of problems with this simplistic model. Obviously, when you buy an NFT, someone might take it down from that website that you've bought the URL location at, so that's one problem. There's also the problem of what's called copy minting, which is when you cut and paste an image and resell it when you don't have the rights to it, basically IP theft. One of the big challenges with NFTs is when you buy an NFT, there's nothing said about the rights that you have to use that NFT. NFT is a digital games character. If I buy a digital games character online, a 3D asset, how do I know I can use that in my game and I can go sell that game? I don't, because when I buy an NFT, there's absolutely nothing said about what rights I have or licenses whatsoever. Okay, this isn't great, and it's probably the reason why people buy NFTs. It probably shows that the reason people that buy NFTs kind of buy them because they think they can sell them for more money to someone else, not because they actually want to use them as a creative artist. Because they don't say anything about rights. But we started looking into whether we could fix that using, again, this idea of provenance and C2PA. So, remember that C2PA is all about embedding a manifest inside an asset that describes its creation provenance, who made it, using what tools, that kind of thing. It's the story of its creation. NFT, as I mentioned, is all about ownership provenance, who owns an asset and who owned an asset. So actually they're both kind of orthogonal aspects of provenance. One's about how something got created, one's about how something's been owned. And put them together and you can start mitigating some of the threats I had on the previous slide. So for example, there are some integrations now with NFT marketplaces where you can buy and sell these NFTs that will check an asset for this C2PA metadata, and we'll see if the person that's selling it is the person that created it, and red flag it if it's not. So this is one of the ways that these two technologies can come together to help fix these problems for decentralized content trading. Why not? I'll put it up. Very briefly, here's a diagram from one of our recent papers. It's a system we called Aquila, and the idea of this diagram, very briefly, is that we are trying to extend
Incorporate attribution,
not only to
which is basically the fusion of the C2PA creation provenance with the ownership provenance, which is at the top, but also we're trying to fuse it with a rights system that allows creatives
to issue usage rights to rights holders, and even allow those rights holders to pay micropayments, royalties back to the creator when they've used the asset for different purposes. Which brings us really to our final kind of point, which is how we believe this framework could perhaps underpin an entirely new model for the decentralized creative economy and digital work in the future. So this Aquila system I mentioned, we published it earlier this year. It's a prototype of an end-to-end framework, basically for recognizing and rewarding creatives for the use of their work. And it creates a decentralized market for content rights. In the paper, we focus on this quite timely problem of sort of creative contributions to generative AI. Remember, generative AI model is trained on millions, if not billions, of images of creative works. Wouldn't it be great if we could look at a synthetic image produced by such an AI and figure out which training data was most responsible for its creation and recognize and potentially reward those creatives? With a combination of computer vision to do that tracing, that visual attribution, and this Aura framework that extends NFTs to enable these micropayments of royalties, we can start looking at what a system like that might in the future perhaps enable us to do. This system C2PA that creates manifests inside images, talking about how that image came to be created, can be equally applied to synthetic media. Why not? There's no difference. It's all just media. So in this diagram, we're showing how a synthetic image, an AI-generated image at the top
model. So that top image, that synthetic image, has a manifest which points to as an ingredient the AI model that created it, and the AI model has a manifest that points to ingredients which are the training data that made that model.
Okay? And those training data items are linked to NFTs that tell me who owns those images. So when I look at that synthetic image and I say, I want to make a donation to the creators who donated the training data in order to generate that image, I can make that trace all the way through the graph back to the owners and make them my owners.
Yeah, and this is an example of what that would look like in that verified site that I showed you earlier. I drop in a synthetic image. This is an example of a synthetic image of a cat made by something called Dream Booth. So Dream Booth is a Google technology that basically will fine-tune one of these general generative AI models that's capable of generating anything, more or less, and make it generate instances of a specific object. So if I say I want to see a cat on the beach, a generic kind of AI will just give me lots of images of a cat on the beach. But if I want my cat on the beach, then I can show this Dream Booth technology a handful of images of my cat, and it will specialize its generation to produce my particular cat on the beach. Not that that's my cat, but it's just an example. So, so what this is showing here is that when I drop that image in, it's showing me the provenance of that synthetic image is to this Dream Booth model, which in turn has been trained by these handful of images of my supposed cat. And you can see the content credentials there on the right. So, in principle, I could then credit those 5 or 6 owners of those images. But then, as I mentioned, the idea of generative AI is that it's not trained on just 4, 5 or 6 images. It's trained on millions or billions of images. So how does this idea scale? I mean, clearly, if I've got a synthetic image and I want to start rewarding creatives and 1 billion of them contributed to my generative AI model, I'm not going to split $1 1 billion ways and give them all a tiny bit of it. This is where the visual attribution comes in. We want to know which specific subset of the training data is most likely to have caused the generation of that image. And this takes us all the way back to a technology that we explored with the National Archives. And the idea here was to use this visual fingerprinting technology again to trace design provenance. Remember that book of the design swatches? So what we showed was that we could take fragments of design from that tome and match them to other bits of design in that tome. And actually that's what we need to do if we want to trace the provenance of a synthetic image. We want to see which bits of training data have been remixed by the generative AI model in order to create the synthetic image. So we reused that technology that we initially did for an Arts Council project for this purpose of visual attribution. And you can see here on the left-hand side an example of a synthetic image. We've zoomed in on a bit of it, and you can see that that patch matching technology has identified, that fingerprint matching technology has identified patches in the training data that are most responsible for the generation of that synthetic image. And it's even given them a score, a credit assignment. We could imagine maybe one day people might use that score to attribute reputational credit or even financial reward. Here's an example of the same, well, it's the same thing really, but it's just on a different data set. This is using a model, it's a public model called Stable Diffusion that's been trained over a data set called Lion. Now, Lion is basically a data set that's been scraped from all over the place and contains quite a lot of public images, they're all public images, a lot of product images. And you can see that here, actually, the model, the synthetic image, bears a striking resemblance to the training data that has been identified by the system. It's basically memorized the training data. This is what happens if you have lots of near duplicates in a training set, it tends to get memorized. But yeah, that wasn't the case with the Adobe stock data set, because Adobe stock's like a marketplace where creators can sell their images, but there's a lot of content moderation put around that so that product IP, for example, images don't get accepted into that marketplace. So you don't see the same sort of traceability happening there with those sorts of images, and it can match styles as well, which is quite interesting. Let me show very briefly a video demo. I don't think there's actually there might be audio. Let's try it.
We're using the Verify web app to view the CAI content credentials that are shipped inside every stock image. This metadata, called a manifest, describes the provenance of each image, which creative made it, and how. Dreambooth is a gentech that can specialize generic diffusion models, like Stable Diffusion, to create images of a specific object like this fish in a swimming pool. Here we've modified Dreambooth training to create content credentials that describe the model and its ingredients, which are those fish concept images, which in turn have their own provenance as we saw. When we drop that synthetic image into Verify, we can see its end-to-end provenance embedded using the content credentials metadata. The synthetic image shipped with a manifest inside, describing the model it came from, which in turn links back to those concept image ingredients, so recognizing the creatives that made the image. As a consumer, let's say that I come across that synthetic image of the fish in the swimming pool online, and I want to reward the creatives that made it happen, who contributed those concept images of the fish. Some of those concept images are NFTs owned by their creators. The Aquila framework enabled those creators to assign training rights for those images, and also enables those creatives to receive donations and royalties for their use in Gentech. In this demo, the micropayments to those creators are being made in a cryptocurrency. Here we're showing the creator's wallet is empty, and using only the JPEG file of that synthetic image, I'm going to use this command line tool to send a donation to those contributors. The tool uses the content credentials metadata present to trace back to the concept images. 10 of them are registered as NFTs, and the cryptocurrencies distributed to the current owners of those NFTs. We can see here the transactions completed, and now the creator can withdraw their funds to their own cryptocurrency wallet, receiving the reward for their contribution to that image.
Okay, so in my last slide then, I just want to summarize and say that, provenance, I hope I've convinced you that provenance is a good way forward to help ensure media authenticity. Those different technologies, metadata, fingerprinting, watermarking, all coming together to create a solid provenance layer on which we can build strong statements about where an image has come from and help users make more informed trust decision about the media they encounter online. But on top of that, authenticity is just the start. We can start layering on new ways to create value for artists through content trading, and maybe even affect the path of creative practice in the future and create entirely new ways to work. So authenticity is just the start.
I'll end by saying provenance to authenticity and beyond.
Thank you very much for such a comprehensive and wide-ranging view of a subject that I suspect not too many of us have dabbled in at all. And we'll run the risk of seeing whether we can in fact get the audience to ask any questions. With a bit of luck, we'll see what we can do. Let me try and see if it works.
John, thank you very much. I just found that absolutely fascinating, the way you explained so much information with such a short time. I just want to ask you a question. So obviously I realise that your research students are working with imagery, with likes of Adobe and such like. But is the problem for audio an altogether different problem, or are some of the basic fundamental principles similar?
Yeah, that's a great question. So the question is around whether audio, presents the same problems and solutions. I would say it definitely presents the same problems. People would want to make statements about the trustworthiness of audio files of speech, and indeed want better attribution for the use of their music and things like this. So yeah, and metadata, fingerprinting, watermarking have all been used in the audio space. I would say, and I should say as well, that the CTPA standard does support audio as well. The differences perhaps the most kind of stark are in the byte space. So the byte space for music is super complex. Like if there's a piece of music played out and someone gets paid for the mechanicals, for the songwriting, the performance, so many different facets of compensation that are applied to music and music industry. And I think that's because the music industry is one of the first
industries to mature in terms of data reuse. If you think about the 80s, which I did see just about, people were sampling music all over the place in the 80s, and they didn't care, they just did it and just remixed it and made a great song, I think, and it was great. But actually it wasn't that great because people were just sampling without compensation to the artists and their music. But the industry matured, and now there's a very comprehensive rights framework around reuse of samples from music. People get paid correctly and so on. That isn't the case for images, and it's definitely not the case for data being used in AI at the moment. In fact, people are just, in many cases, taking it from all over the place without even permission sometimes. So I would love to see the AI landscape and data promise mature to something like the point where the music industry did. But of course, that comes with an extremely complex rights framework, which clearly we've simplified the rights frameworks in the work we've done around the prototypes. Yeah.
Thank you. Yeah, thank you very much. Fascinating talk. Is there a business model behind it? So, who's going to be investing and who's going to be making lots of money?
Well, that's an interesting question. So I run, in my academic hat on an academic research centre called Decade, which is the Centre for the Decentralised Digital Economy, and we're looking into. Okay, so what does that mean, first of all? Okay, so we all live in a decentralised digital economy when you think about it. Like, we could all take an Uber or drive an Uber, or we could all go stay in an Airbnb or rent our house out on an Airbnb. And these are it's like a gig economy, a decentralised peer-to-peer economy that we are often part of when we use digital platforms. But those digital platforms are often centralised. They're run by maybe tech companies and this sort of thing. And the Centre Decade is looking at how we can create decentralised platforms to enable new ways to create value, more inclusive governance of those platforms, that sort of thing. So, what is the business model? Well, business is all a part of Decade, and we're exploring new business models for the decentralised creative economy. Creative industries are decentralised. Everyone is a producer and consumer of content. The days of a monolithic broadcaster definitely are diminishing, arguably. I mean, most under 35 just watch YouTube now, not terrestrial television, for example. So, in this era where anyone can be a content producer, anyone can be a content consumer, how is the money made? What is the business model? I think there are new business models, but they need to be underpinned by strong guarantees about the provenance and authenticity of the digital content being disseminated online. So I think there's a business model in creating micropayments for the dynamic reuse of content produced in this decentralised way through the kinds of rights frameworks that I've shown today. I think that could be a future novel facet of the creative economy, and that could well be where the money is made.
Thank you very much. You've painted an encouraging picture that it's all under control, but listening to the media, it's all rather scary. So, are we safe or should we be scared? And the final observation, I think the detection laws that you've described open the door for lots of money for the claims courts.
Okay, thank you very much for the question. So I think the question first of all was, should we be scared? No, I don't think we should be scared. I think there is a lot of scaremongering in the media, I think, as you were alluding to, and I think that's just the nature of the media, isn't it? People like to sell happiness and sell fear in the media, don't they? But I think there's a lot of people switched on about the risks around, for example, generative AI. Certainly, I think the media is driving public perception of that, and the public perception of that risk is driving politicians to create legislation. Of course, we saw the AI summit here in the UK. There there are other things as well. You know, there was the executive order on AI just in the US just a few days before that. So the regulatory space is catching up very quickly, perhaps much more quickly than we might normally see in the technological space, and people are reacting to it. So, you know, and arguably strong governance technologies could be part of the solution in that regulatory space. So I think there's a lot of hope for mitigating this challenge. Fake news, misinformation, like on my first slide, it's not a new problem. People have been lying since the written word. It's human nature. It's just more apparent now and more prolific with the advent of social media and digital media. Will we ever solve that problem? I don't think so, but I think, you know, we've got some promising technologies on the way, and I wouldn't be scared. I'd be encouraged. But I do work in that space, so I would say that as well.
Thank you.
Your fingerprints, AI, seems almost like being able to fingerprint content rather than the image. Can you talk a little bit more about how you train that AI and how you clearly it's repeatable, otherwise you wouldn't get a hash out?
Yes.
Can you just talk a little bit about that, the concept of how you train that?
Okay, so the question is a technical question about how we produce the fingerprinting AI. The way these sort of contemporary fingerprinting models work is you train an AI using often what's called contrastive training, which means you show a network an example of an original content, and then you sort of augment the content by changing it in lots of different ways. Like I might resize it, I might add noise to it, I might do all sorts of things to it that I want the network to learn to ignore, to be invariant to. And then I can show the network lots of things like totally different images that I want it to be sensitive to. And it will learn the contrast between the signals you want it to ignore, like the non-editorial changes online, and the signals you want it to perceive, like changes that are editorial in the image, like the image of a totally different image, for example. And the attraction of training in this contrastive way is it doesn't require any human annotation. Often always the bottleneck in AI is data, but often the bottleneck in that data is a human has to sit there and say, that's a cat, that's a cat, that's a dog. It's called annotation. If you can get a network to learn without annotation, without supervision, as we call it, self-supervised learning, then a lot of that data bottleneck goes away, and you can train very large AI models very quickly that are very performant. So this contrastive training is an example of self-supervised learning, and that's what we use to train our AI models.
Thank you for a fascinating lecture, and ignoring the very clever technical aspects, I'm struggling with more the starting point. You say that the AI is trained by looking at billions of photographs on the internet. You also say that the billions of photos on the internet don't have any metadata with them. But you're relying on people submitting to some sort of authority pictures with metadata. And once you've got that metadata in your authority, you can then do what you want and progress to do all sorts of clever things. But there's a sort of parallel here with the police database. If everybody is in it, then it's a very useful tool. But if there's only 1% of the people in it, it's not very useful. So could you just say, at the moment, you know, where the world is with all this metadata?
Yes, okay, so let me sort of summarise and paraphrase your question so I can play back, I hope accurately. So it's basically you're describing the adoption problem around the technology, I think, that I've outlined, which is, you know, what good will it be until all the images have this metadata, right? I mean,
that's a bit harsh, but yes.
Indeed, it would be lovely if everything in the world spoke this metadata and respected it and didn't strip it, and it was always present. I mean, it's an adoption curve. It's an emerging standard, and right now there aren't that many images out there that use it, but there is a very steep adoption curve. I mean, to give you an example, There are camera manufacturers like Canon and Leica that are embedding this metadata in their cameras. You can go down the high street today, and buy a camera that's got this in it. It's not all of the way anything, but it's starting to appear in hardware. There are products out there like Photoshop and other products from other companies as well that do implement this standard. And hopefully, one day we'll see news organisations publishing images that contain this. But yeah, it will require time. It's interesting when you look at the sort of draft legislation and comments coming out of governments about online harms, and if you do start reading them now, perhaps in the light of talks like this, you'll start seeing the word provenance come up quite a lot, and talking about how provenance information might or could or should be made available. So maybe that will drive it. But yeah, it's a curve, and we're not at the top of it by any means. We're just at the bottom of it, really. But it's climbing steeply. Yeah.
That's right.
Thank you very much for the lecture. Question on propaganda, because we can accredit artists that created some image or video or any of that content. We can separate fake news. However, is there any works that target propaganda? For example, someone else trying to create fake news from the start, from taking the camera image in a studio, for example?
Well, obviously one of the use cases for this would be to fight misinformation, which would include things like propaganda. I mean, are you asking me if there are any concrete examples that are being used for that right now? I'm not sure.
I'm just asking if there's any research done on that right now, since if you have a journalist, for example, working for media, and then he portrays the news in a certain direction, and then you have another media that portrays the news in another direction. If they're able to access the blockchain and then verify their images, for example, then everyone can see that those images can be traced back. But how can you verify that what's happening on that image is actually true or not?
Right. No, that's a very important point. So what is the system being proposed here? It is like basically a secure pipeline that attests to where an image has come from, like who made it, what's been done to it, that kind of thing. It's very similar, I think, to when you see the little green padlock in your browser, you're surfing, right? You know that the bits that are coming down the pipe to you, down the network to you, have come from that server, guaranteed it's cryptographically signed. But doesn't mean that everything I see coming up in a Google search I can trust, does it? Right? So, what it's doing is it's sort of saying, I can tell you that this search result has come from this server, from this web page, but it's down to you to make a trust decision based on that information. And this standard and the systems that I've been describing to you today are very similar. It's saying, I can tell you who made that image because they signed it with a cryptographic key. I can tell you that it was processed by these tools and these sorts of operations were performed on it. But frankly, it's down to you to decide if that really is a guy, that is, Pope wearing a jacket or something like that. Yeah. So it's not telling you what to trust or not to trust. It's giving you more information to make an informed trust decision.
Forgive me for what's possibly rather a stupid question. It seems to me that a lot of what you've spoken about takes place in a regulated society. I think the danger of deep fake is in a non-regulated society, where deep fake images of, say, a politician making some sort of outrageous pronouncement get somehow onto social media and go viral. And the amount of protestations to try to negatively...
We often talk about sort of type 1 and type 2, or system 1 and system 2 thinking. Like it's a sort of psychologist thing where type 1 or system 1 thinking is like reactive, it's like intuition. It's, you know, if I'm asked I don't know, a question about a puzzle, I might just intuitively like guess and make a quick answer to it, and I react, and the decision's made, and I go on with my life. Or there's system 2 thinking, which makes me really work through that puzzle and think about the solution and take my time and come up with perhaps a better answer. We need both types of systems of thinking in order to function as humans. We can't think carefully about every single operation we as humans do. And the danger with social media, one of the dangers of social media, is that there's too much system 1 reactive, intuitive thinking going on, where people just reshare stuff without thinking about it, and not enough system 2. People need to slow down when they're resharing content online. And that is what this technology should, I hope, help people do. They see that icon there on an image in Twitter, let's say, X, sorry, maybe they click on it, or maybe they think, oh, I could just click here, it's just a small action, just click here, and it's going to tell me, oh, wait a minute, that wasn't cryptographically signed by the Prime Minister, it's not got any signature, or it's been signed by some random guy, and it's like, oh, that looks a bit iffy, maybe I won't share that now. And that should slow people down, make them just think that extra second before they reshare, apply that system 2 thinking, and that will go a long way to mitigating, I think, the spread of misinformation online. So that's the sort of thing we're trying to do. We're not automatically trying to block content. As I say, we're not making trust decisions. We're helping people make more informed trust decisions about content they encounter online. And that's one way I think it will be effective. I hope that answers your question. Lots of it.
Okay, I think we're getting to time for a last question.
Thank you very much. Very interesting lecture. You spoke a lot about donations to the people who created source assets or source artwork. Could you expand on that a bit more? Because I just feel that maybe, you know, the content creators, artists, etc., are going to get very shortchanged, and the use of the word donations, you know, the big companies going to say, oh yeah, let's donate to this guy over here, you know, and Spotify, YouTube, they're pretty bad on reimbursing content creators.
Okay, yeah, no, thanks for the question. That's a good question. So why did my examples at the end there focus on donation? Really, it's because these technologies are so new, they need to exist in an ecosystem, and spinning up that ecosystem is like a chicken and egg problem. Like, why would people use this technology and publish to it if it didn't exist? Why would people pay for it if it didn't exist? So yeah, we just made a very simple example there, you know, with apologies, where, you know, we imagine there's an image up there that you like, there's a piece of media, it might be a video that you liked, and you want to donate some money to the creator of that. And, you know, there are models for this that are quite popular. There's Patreon, there are other platforms out there right now where, you know, I mean, this happened a lot in the pandemic as well, right? There were people who couldn't be making their TV shows anymore in the studio, so they made a YouTube channel. My kids used to watch various CBBC presenters doing this, and then, you know, people would, you know, buy them a coffee effectively, you know, send them a small donation if they like the program, and I think it was relatively successful. So there's definitely is a model for sort of crowdfunding creatives through donations, and I think that does exist. I don't want to give the impression that that's the only model for compensation that we were considering in our work. We were considering a general rights framework where I could issue, let's take your example of a company, I could issue, I don't know, a TV company a right to use my video that I took in that gig, and if they do, then I could receive a micropayment for it. So it's not a donation; it's a contract in that case. And you know, the framework, you know, the way we've designed it, we believe it to be general enough to support that. The challenge that we've got as a centre and as a, you know, research entity, I mean, you know, to study the success of that as a model for the creative economy is super challenging. We have to deploy it in the wild. We have to get lots of players to interact, to use this decentralized platform. I would love to see it deployed and studied in that way. I hope we have enough time in our centre to do something small scale like that, but it will be challenging to see if it succeeds or not. But I think it has potential to be a new facet of the creative economy. Yeah.
Thank you very, very much indeed for that. And would you like to join with me, the audience? John.